Hi, do you have a problem with relation? Don't worry, we can make you understand better in this subject. Let's go. Relation has three parts. Part 1, definition, properties, operation. Part 2, representation. Part 3, relation database and equivalent relation. We go to the part 1 first, which is definition of relation. Definition of relation. Relation is relationship between element of set. Second, the direct way to express relation is by using ordered pair. Third, ordered pair is called a binary relation. In other words, we use the notation ARB to denote as a AB belongs to R, and A alpha B we denote as a AB not belong to R. For example, let A is equal to set of people, let B is cost, let F is relation of which people enrolled in this class. We can conclude that all pair of set F belong to R, while ordered pair for color IT is not belong to R, since color IT is not in the F. Next, we go to the part 1, which is function as relation. Function is assign a unique element of set B to each element of set A. Graph of F is set of ordered pair AB such that B is equal to FA, where A insets A and B insets B. Since the graph F is subset A times B, then F is relation from A to B. Next, you can read by your own. Next, we're moving to the relation on the set in part 1. For your information, a relation on the set A is a relation from A to A. For much understanding, a relation on the set A is a subset of A times A. But I still do not understand. Don't worry, let me show an example. For an example, let A 1, 2, 3, 4, which ordered pair are in relation R where A divides B. We assume A be in set A, so the answer for R is 1, 1, 1, 2, 1, 3, 1, 4, 2, 2, 2, 4, 3, 3, and 4, 4. That's all for definition and relation. Bye!
Wait, we are not done yet. Welcome to the properties of relation. There are 6 properties: reflexive, irreflexive, transitive, symmetric, antisymmetric, and asymmetric. Sounds confusing, right? But let's move on deeper with a fresh mind. Embed what you learn later into your brain. First of all, reflexive. It means there exist all elements A in set A such that the ordered pair of the same element A exists in R. Easy, just remember A. Let's take a quick look on this challenge and say the answer fast. So easy. First one is A, right? So 1, 1, 3, 3, 5, 5, 7, 7, 9, 9. Okay, next question. It is true for 0, 2, 9. Just look at them. All 0, 0, 2, 2, 9, 9 are AA. Then the elements are obviously 0, 2, and 9. It is a big false. Why? 3, 4 is not AA. And since there are element 3 in the relation, we can see that 3, 3 is not also exist there. Now we come to the confusing symmetry family you are wondering about. Symmetry, antisymmetry, and asymmetry. Symmetry is when there is AB, there must exist BA, just like its name, symmetry. Antisymmetry look like reflexive, but the main difference is not all elements in set will be on relation as an ordered pair. Just look at it, there's no 3, 3. Divisibility is important in this relation. If both numbers are the same, then they can't divide by themselves to obtain a natural number. So F can be divided by 4, but 4 is the can't. Asymmetry is when no BA, there's no 2, 1 on the relation we are seeing. Let's not forget about irreflexive. Simple, it is opposite of reflexive. No AA should be in the relation. And last one, transitive. As the name suggests, it is transition from one element to another element. Let's say you are from element 1 to 2, then 2 to 3. If we sum up, you'll get 1 to 3. Hence, as the formula suggests, AB, BC, then AC. Embrace the next one, combine or power, which is better. Combining relations. As the title, we combine two relations, namely R1 and R2 of two sets. Let's say set A and set B. Either can be union, intersection, or the difference between the relation. The composite of R and S are as follows. We write them as S small circle R. From set R, there is 1 0. Then, we'll find 0 as the first element in S. There you go, 0, 2. Then, you do just like transitive. 1 0, 0 2, then 1 2. Yeah, another 1, 0 3 in S. Then you will get 1 3. Lastly, power relation is the relation on set A consists of power denoted as n. N can be 1, 2, 3 or even 10. R power n is R composite with R n times. The theorem said it is transitive if and only if R is subset of R for n greater than 0. That means R cannot have a negative power, so that R can be transitive.
So let's continue with part 2 of chapter 9, relation. Part 2, representation. There are two ways to represent a relation. First, 0-1 matrices, and second, directed graph or digraph. The first way is 0-1 matrices. Suppose that R is a relation from A to B, then the relation can be represented by the matrix MR equals to Mij, where Mij equals to 1 if Ai and Bj exist in R. Suppose that A is a set of 1, 2, 3 and B is a set of 1, 2. Let R be the relation from A to B containing AB and A is larger than B. Then R is a set of ordered pair 2, 1, 3, 1 and 3, 2. Notice that ordered set exists in R is equals to 1 and the one that doesn't equals to 0. Reflexive relation. R is reflexive if and only if Mii equals to 1 for all I. In other words, all elements are equals to 1 on the main diagonal. Symmetric relation. Let R be a binary relation on a set and let M be its 0-1 matrix. R is symmetric if and only if M equals to M transpose. For Boolean operation, we will learn about union operation or operation. If one of the input is equals to 1, then the output is equals to 1. Next is intersection operation and operation. It needs both of the input to be equals to 1 for the output to be equals to 1. The rest is equals to 0. Let MR1 equals to and MR2 equals to. Thus, MR or R2 is equals to and MR and R2 is equal to. Representing composite of two relations. From learning about Boolean product, we know that matrix S composite R is equals to MR and MS. The composition of relation such as R2 can also be found with matrices and Boolean. Next is the second way, directed graph or digraph. Let V be the set of vertices and E be the set of edges in ordered pair AB. A is initial vertex and B is terminal vertex. We will use arrow to display the relation. To display the digraph with V as a set of A, B, C, D and E as a set of ordered pair, notice that every element in V become the vertices and all pairs in E become its edges.
Part 3. Relation database and equivalent relations. What is a relational database? A relational database is a type of data that store and provide access to data points that are related to one another. Usually, database is organized into a table. Each row in the table is a record with a unique ID called key, and the column holds attribute of the data. Relational database. The data consists of n tuple or record. Each of the n tuple is called field. Field are entries to the n tuple. Sounds confusing, right? So let's look at the example. Example 1. Consider a database of students whose records are represented as 3 tuples with the field student name, ID numbers, and GPA. So this is the answer. Easy, right? Just follow the name, ID number, and GPA. Let's continue with the definition of an array relation. Let A1, A2 until Am is set. An array relation on this set is a subset of product A1, A2 until An. The set A1, A2, until An are called the domain of the relation, and N is its degree. Example, an array relation are the basic relational database management system. Column of the table represent the attribute of the relation. Row or record contain the actual defining the relation. Primary key. A domain of an array relation whose value uniquely determine the n tuple. No two records have the same value from the same primary key. For example, in the previous example, which of the following fields are the primary key? Yeah, the answer is student name and ID student. The definition of projection. The projection Pi1 until Pin makes the n tuple A1, A2 until An to the m tuple Ai1 until Ain, where m is less than n. Okay, let's take a look at the example. What is the result of applying projection P13 to the student table? So this is the before projection and this is the after projection. The definition of join is to combine two tables if they share some identical field. In this example, Y relation and R relation share some identical field which is name. Hence, the join is as follows. Is equivalent relation. A relation on set A is called equivalent relation if it's reflexive, symmetric, and transitive at the same time. It is to relate objects that are similar in some way. Two elements that are related by an equivalent relation are called equivalent. Example, let S be the set as follows. Do the following collection of set partition of S. It's clearly that number 2, number 3, and number 6 is wrong. Example, let S be the set as follows. Do the following collection of set partition of S. It's clearly that number 2, number 3, and number 6 is